So what is polymorphism? So polymorphism means many forms, and within object-orientated programming, many forms applies to the methods that we create and how they can exist in many different forms. So polymorphism is split into static, also known as compile time polymorphism, and also dynamic. So we're going to now take a look at how we can apply both of these with an example. Okay, so to demonstrate polymorphism, I'm going to create an employee class, and this employee class will be used to count the number of steps an employee takes to get into work. So we'll just have a regular method here called public integer count steps. And the whole idea here is that this count steps method will tell us how many steps it takes for an employee to get to work if they don't really have to commute very far. So this is the number of steps it will take for that employee to go from the bottom of the building to their desk. So we'll just return 30 here. Now this count steps method is the first form of this method which we're going to create. And what we can do is create a new form of this count steps method by changing the method signature of the count steps method. And a method signature within Java refers to how we define a method name along with the parameters of that method. So this will be the number of parameters that it contains, the type of parameters which they are, and also the order. So I'm just going to demonstrate this a little bit further. So we can use static polymorphism to provide a new form of this method, count steps, but this time it will take in an integer which will tell us how many miles they've walked to work. So miles walked. And what we will do is we will add 30, which is the amount of steps it takes them to get from the building to their desk, and we will add that to the number of miles they've walked, multiplied by 1500, say. So we'll do return 30 plus 1500 times miles walked. And this is the first kind of form of polymorphism which we have. We have the exact same name of the method, but it exists slightly differently because now we're taking in one parameter, and that first parameter is an integer. We can also include another form of the count steps method, so public integer count steps. This time we will take in an integer for the miles walked, and a second integer for maybe miles ran. Is we can return 30 plus 1500 times miles walked, and then plus, let's say when you're running you take fewer steps, so you could do 1000 times miles run. I'm just going to demonstrate this with a simple public static void main method in a class below. So you can just have an application class below and the public static void main method. I'm just going to create an employee, and then I will just system out a few of these methods. So employee.countSteps, and then we can say an employee that walked 1 mile to work, how many steps they took, and one who walked 1 mile and ran 2 miles. So I just run this. So we can see that 30, 1530, and 3530 are all printed out to the bottom. So one thing we can't do with this method signature is change the return type. So if I were to do public string count steps, and I would just to return a string here, we'd have a compile error here. And if we hover over it, we can see that IntelliJ will be telling us count steps is already defined in employee. And that's because we have two methods with the exact same method signature, which is the name and 0 arguments, but two different return types. So when it comes to polymorphism, it only refers to the name of the method, and then the number of arguments, the type of which those arguments are, and the order of which those arguments are. If I change this here and change the parameters, so let's say we take in a string of the name, an integer of miles walked. This is a different signature because we have that same method name, but we're taking a string as the first argument and not an integer as the first argument as we have above. We can also we can change this to an integer. This will create a problem because they have the exact same signatures, but if we were to provide a third argument here, a boolean of I've got the train, that would be different. So this is how we can apply static polymorphism. Okay, I'm just going to clean this up a little bit. And I'm now going to move into dynamic polymorphism. Dynamic polymorphism refers to the inheritance concept of object-orientated programming. And we're going to look at how these methods can have different forms when we use inheritance. So I'm going to create a class below the employee, and I'm going to call this class athletic employee. And an athletic employee would be slightly different to a regular employee. Let's say they generally take fewer steps than the regular employee. But we're going to have them extend the employee class, so now they already have these methods up here. So if I go below, I can now create an athletic employee class, and if I run this, we will have the exact same output as we had with the employee class. So one thing to note is that what we've done here with the static polymorphism is that we've overloaded this method. So we provide different forms of it through the parameters. But what we're going to do with the athletic employee is override the method by providing the athletic employee with its own implementation of these methods. And this is how we can achieve a different form of the method through inheritance. So I'm just going to click generate, override methods, and we can see from the employee class we can override two methods. And when we first override the methods, what it's going to do is return super.countSteps for the countSteps method, and that's basically what the athletic employee currently does, which is call the parent class method. But instead what I'm going to do is return 20. And then for the overloaded method of taking an integer in, what I'm going to do is return 20 plus 1200 times the miles walked. And this will be slightly different. So now if I run this method, if I run the main method below, we should have slightly different results. So we have 20 and 1220. The reason this type of polymorphism is called dynamic compared to the static polymorphism is because the different forms of the methods which we are using are executed at runtime as opposed to being created at compile time. But when it comes to execution, that is when these overridden methods might be executed, and it all depends upon how we instantiate this employee instance. So in the main method we have an athletic employee with reference to an athletic employee, so that means it will always call these overridden methods of the athletic employee. And to demonstrate the other types of dynamic polymorphism, I'm just going to add another method, public void run, and I'm just going to system out running. And what we're going to see here is that if I try to see which methods the employee has access to, we can see this run method down here. What we can also create is an employee which references an employee, and this means the employee will be referencing the countSteps methods from above. If I were to run this main method, we would see that the output is slightly different. So we have 30 and 1530. Now if I were to do a system out, employee dot, we can't see that run method, and that's because we're referencing an employee class and it can't see that run method from the athletic employee class. The final type of dynamic polymorphism is an athletic employee with reference to an employee. So what this means is that the employee will only have visibility into the methods of the employee class. However, the implementation of the methods count steps and count steps with a single argument will be referencing the overridden methods of the athletic employee class. So if I were to run this method, we would now see that we have a slightly different output to conclude this video on polymorphism.